So in this video, we're going to be focusing on non-permissible values. Non-permissible values are all the values which make the denominator of a rational expression equal to 0. So let's start with the first example, which is 4a over 7bc. And in this, we want to find a value for b and or c, which makes this whole thing equal to 0. So this is pretty simple, as b cannot equal 0 and c cannot equal 0. For this next one, it may look a bit more challenging, but it's not, as we can actually create equations in order to help us solve for the non-permissible values. So for like the first, this part, we can make an equation x plus 2 is equal to 0. And I made it equal to 0 is because if this is equal to 0 and you multiply by x minus 3, it's gonna equal 0, because anything multiplied by 0 is always gonna be 0 in math. With this equation set up, we can use simple algebra to solve it, so we get x equals minus 2. This minus 2 basically means if this x is minus 2, then this whole equation is gonna be 0. That means this negative 2 makes this whole denominator equal to 0. So it is a non-permissible value. So we can write that down because it's not equal to negative 2. For the next one, we have x minus 3, which is equal to 0. And we can do x is equal to 3. And from that, we can see that x cannot equal 3. For this next equation, it may look a bit confusing. However, it actually is pretty simple, as we only have to focus on the denominator. And these signs are to the power of. So this would actually be 67x squared and then x squared minus 4. So for this, what we first need to do is factor the denominator, which is gonna be x plus 2 and then x minus 2, as it is the difference of squares. And we can use this same formula method up here. So we can get x plus 2 is equal to 0. That means we get x equal to minus 2, which we can see that x cannot be minus 2. And then we have x minus 2 is equal to 0. Then we get x is equal to 2. That means x cannot equal 2.